Alright, this is a demonstration of our attack for CS4404. I'm trying to get the tech on video, so really quickly, if I do a dig for my site.show, I get 10.4.17.4 is the answer. And if I go to my site.show, this is what I get shown. So really quickly, I need to add a delay here. I want to start the attack as quickly as possible so that I can capture on video. Dump the cache. Alright, so in essence what I did was I did a dig and I went online and resolved www.mysite.show, and this machine here is the client machine, so this is what I'm using to demonstrate the attack. It points to machine number 3, which is the recursive resolver. Really quickly, just want to mention that the IP naming scheme, the last octet is a reflection of the machine, so this is machine 1, so it's .1. So yeah, this is the client machine, just to show the attack. This is machine number 2, this is our attacker. So it's running a fake version of www.mysite.show, and it also is running the attack and a DNS server. I'll explain a little bit more in 1 second. This is the recursive resolver, so this is the DNS server we're trying to attack. This is basically bombast, this is the DNS resolver outside of its network. And this machine, it gets queries, and I can show really quickly in the etc bind root zone. So any query it gets, it sends to the root server, which I replaced the original db.root file, which had the 13 root servers that you normally use, to just point to machine number 4, which is for our infrastructure, the root server. So any query this machine gets forwarded to this machine over here, and it's running the website, the real mysite.show website, just because we didn't have a 7th machine to have that running on. So this has 2 functions, being the root and being the website host, the server. And I can show the zone file for this machine as well. So it knows about itself. Its time to live is 0. All these machines have a time to live 0 for their responses, just because we want to be able to look into the dump of the cache and really quickly be able to identify whether or not we were able to get a hit or not. So yeah, it gets a query, and if it has .show as the top level domain, it gets sent to this name server, which has this IP, which is machine number 5, this one over here. So I can leave this. So machine number 5, so we added a 5-second delay, which is what you saw me do in the beginning of the video. That's just to give us a really inflated time space attack surface. So this machine takes 5 seconds to respond, which gives us enough time to send a bunch of fake responses from the attacking machine. And this machine, I can show the zone file. So yeah, it gets a request, and any request it knows about itself. If it's mysite.show, it gets sent to this name server with this IP, so it's machine number 6, and that's the authoritative name server for mysite.show. So I can leave here, and yeah, all of that is the time to live of, well, it should be 0, but it doesn't get cached anyway. Lastly, this machine, this is authoritative name server. We were running a delay on that one, but we switched our attack and found that it works a lot better. So let me show the zone file really quick. Time to live 0, and yeah, it's the authoritative name server. So when a request comes in for mysite.show, resolves to this, to ns1, ns2. We have a second name server. We don't really use it. We don't have it set up anyway. We just have it here for really no actual useful reason. And then it gets resolved to machine number 4, which is this one running the server for www.mysite.show, and we have mail, FTP, but we don't use those. We just use www. So we have the attack running. I can see that it hasn't successfully, hasn't been successful yet, but let me describe what the attack is doing. So here's the Python script we're running. We're using Scapy to construct our own query and response packets. So we do 10,000, it's set up to run 10,000 attacks. So what we have here is the authority and then a random prefix or a bunch of random characters, and we take 5 of these characters in random order and append it to the authority and send a query out to this machine. And the packets, the responses have a spoofed IP of .5, so we make it appear as though it's coming from this machine when it's really not. And this is the IP that we're sending it to, which is our recursive resolver. The recursive resolver is set up to send all of its queries from port 33,333, which is the one we send all of the responses to. And so the script generates 10,000 fake URLs. And then once it has that fake URL, which like you can see here, it sends a query trying to resolve that URL. And then right after sending it, we send 300 response packets. So we generate a random transaction ID. This is what we're trying to match up to the query that this machine sends. So we add that transaction ID to our response packet. And the response packet, in essence, it doesn't have any authoritative answers. All it has is the name server that this machine should be using to resolve any queries related to my site.show. And those are all cached for 84,000 seconds. So the only thing that's being cached is the answer here. So none of the responses from the other DNS servers are being cached. And yeah, it sends the NS record for my site.show, and then it sends an additional record that has its IP, and that gets cached. So anytime a query comes in for mail or www.mysite.show, instead of pointing to machine number 5, it points to machine number 2. And then I can show, I believe it, yeah, so we have this DNS server, which I can show because I can see the attack has not worked. That's T-Shark. Okay. Oh, yeah, sudo nano db. Right, so here's the zone file, and we actually do cache everything for 10,000 seconds, all the responses that get sent to this machine, which I believe actually worked. Hold on. So if I do a dump of the cache file, oh no, wrong thing. Yeah, alright, it worked. So let me stop the attack. So yeah, did I exit out of there? I probably did. So what you saw was all of these were saved for 10,000 seconds, and the only reason I save any request, or I cache any request that comes into here, so I can identify with Wireshark which of the responses was the one that actually managed to line up, which might take, I'm gonna try and find it, but it does take a second. So the first hit that I got, actually, let me do this first. So if I clear the data now in the client, so he wants to go to my site.show. And when he goes up, this isn't the site that we saw before. It's character assassination because he said mean things about bombast superior internet. Oh, what a shame. For us to show. Shouldn't have done that. So the attack worked. I'm gonna pause the video because I have a 10-minute limit on what I can record, or maybe I don't have to. Let's see. If I get down to 30 seconds, I will pause it. But alright, so this is the first response that was cached, and then I'm filtering out all the unsolicited ones. So yeah, let me pause really quick until I figure this out. Alright, with 20 seconds left to go, I found it. Right, so here is the query we sent, and it had the ID field of OXF994, and then the response is right here, and we were able to match it. So, yeah.